Hi guys, this is another video for us for balancing equations. This is Mrs. T. Mrs. T, I'm a chemistry teacher at Calhoun High School in Merrick, New York. And here we're going to do this. So the reason why we balance equations is because of the law of conservation of matter. Okay, so this tells us that matter can't be created or destroyed, which means that when we write our equations, we can't have a different number of moles of atoms on one side than the other. So when an equation is balanced, what we're getting to is that we're getting to the same numbers of moles of atoms on each side of the arrow. So after an equation is balanced, it shows that there's the same amount of matter before the reaction, which is our side before the arrow, and after the arrow, which is what happens when the reaction is complete. So if we wanted to balance a quick one here, if we look again, we're going to say the arrow is like an equal sign. So since our arrow is like an equal sign, the amounts of reactants and products on each side should be equal. So in order to check and see whether they are equal, I am going to go through and look at each symbol. Remember, every capital letter represents a new symbol. Underneath the arrow, I will write each symbol that shows up on each side. Then I'm going to count up the number of moles of atoms of each element as it is. So K has no subscript right here, so that's an understood 1. K again has no subscript, so that's an understood 1. So far our potassiums are in balance. N has no subscript, so that's a total of 1 before the arrow. Here N has no subscript, it's a total of 1 after the arrow. But our oxygens, there's a 3 here, so there's 3 moles of atoms before the arrow. But here I have 2 in this compound and 2 in this element. So that would be 2 plus 3, that would be 5. Oops, I didn't add that correctly. It wasn't 2 plus 3. Sorry about that. That would be 2 plus 2, which would be a 4. So in order to balance this, I'm going to start putting in what are called coefficients. Coefficients go in before the formulas. They can't go in between formulas. They can only go before entire formulas. And when they go before the entire formula, they multiply by whatever comes after it until the next arrow, until the next plus sign. Okay, so anything that's all part of the same formula will get multiplied. So if I wanted to start, I'm going to try by putting a 2 here and see what happens. So that multiplies by this K, making it a 2, multiplies by the N, making it a 2, and multiplies by the O, making it a 6. If I then also put a 2 here, that multiplies by the K, it multiplies by the N, and then this represents 4 O's plus another 2 here, and 4 plus 2 is 6. So when I add them up, my numbers of moles of atoms are the same on each side, and if I wanted to, I could go ahead and put a 1 here, or I could leave it blank. So if I wanted to put the 1 there, I could. If I wanted to leave it blank, I could. So what this means is that potassium nitrate, for every 2 moles of potassium nitrate that react, we get another 2 moles of KNO2, potassium nitrite, and we get 1 mole of oxygen gas. If we want to try one that's a little bit more complicated, this one is called combustion, but again, we're going to put an equal sign next to our arrow, with our arrow here to show us that everything has to be equal on each side. So we're going to do our C's, then our H's, then our O's, and we're going to see where it takes us. So before the arrow, I have 4 C's. After the arrow, I have 1. And if you want to pause here and write down the reaction and see if you can get started and kind of pause and restart as you need some help, that's fine too. So I have 10 H's before the arrow, 2 H's after the arrow, 2 O's before the arrow, and here note that the oxygen is in 2 places after the arrow, so it's 3 after the arrow. When I see something with C's and H's and O's, usually what I like to do is start with the C's. So I'm going to go ahead and pop a 4 in right there to get my C's balanced. And now that's 4 C's, and that's 8, 9 oxygens, because this times 2 is 4, and then there's another oxygen here, so that's where my 9 came from. To get 10 H's on this side, I'm going to put a 5 in, and when I put that 5 in, that's 10 H's, but now that's 8 and 5, that's now 13 oxygens. So if I want to get this all into balance, I'm going to put a coefficient here in order to get my oxygens balanced. And if I put a 6 and 1/2, oh boy, I'm pressing a button. Hold on. There we go. If I put a 6 and 1/2 here, that 6 and 1/2 times 2 gives me a 13. So I have 4 and 4, 10 and 10, 13 and 13. But there's a problem with this. When we balance equations, we have to use the lowest whole number ratios. And this 6 and 1/2 is not a whole number. So what I'm actually going to go in and do is, because this is a 1 to 6 and 1/2 to 4 to 5, I can go in and double all of my coefficients, and my coefficients become 2, 13, 8, and 10. And so if they asked me for the sum of the, and I'm messing this up here, if they asked me for the sum of all of the coefficients, it would be 2 plus 13 plus 8 plus 10, which is 33 would be the sum of the coefficients. So this was just going back over 2 of the balancing questions from the AIM, and hopefully that was helpful for you. Hopefully this went back through some of your questions that you had. And again, we balance equations because of the law of conservation of matter. We want to have the same number of moles of atoms on each side, and that would show us that matter wasn't created or destroyed in the process of the reaction. If you have any other questions, you can certainly respond back to one of my remind messages or send me a quick email at school, and if you can't come into extra help, or you can certainly come into extra help too.